And in the chapter 5, we also have a fundamental identities, right? Do you still remember how do we get the fundamental identity? What is the fundamental identity? I say this identity you should never forget for your whole life, right? What is a fundamental identity? Sine square alpha plus cosine square alpha equal to 1, right? How do we get this fundamental identity? Because the point of the intersection xy is on the unit circle, right? So it satisfies the equation of the unit circle. So x squared plus y squared is equal to 1. And then you have the sine alpha equal to y, and cosine alpha is equal to x. So replace this x and y. You have the cosine square alpha plus the sine square alpha equal to 1. Or you may write this as the sine square alpha plus this cosine square alpha is equal to 1. Either way is okay. Okay. So this is the fundamental identity. Now from now on, generally we use the x in place of the alpha as the variable. So right now we just use x as the variable. Then we have the sine square x plus cosine square x equal to 1. And from this identity, we may derive other two identities. And together, the three identities are called the Pythagorean identities. So now suppose the sine x is not equal to 0. Then we may divide both sides by sine x. So now we divide both sides by sine x. Then we get sine divided both sides by the sine square x. Then we have the sine square x over the sine square x plus cosine square x over the sine square x. And this is equal to 1 over sine square x. Now the sine square cancel. You get 1. Right? Now what is this? Cotangent square x, right? By the identities from the definitions, this is the cotangent square x. So cotangent square x. And then what is this? Cosecant, right? It's the cosecant square x. Okay. Now we got a new identity. Okay, it's the 1 plus the cotangent square x equal to cosecant square x. Okay, both are right? Cotangent and cosecant. So now, if I divide both sides of this identity by cosine square x, let's see what we get. So we have the sine square x divided by cosine square x and plus cosine square x over the cosine square x, and which is equal to 1 over cosine square x. So now this first guy is the tangent square x, right? So you have the, from here, you got the tangent square x, and then plus 1, and then 1 over the cosine square x equal to what? Secant square x, right? So secant square x. Then we got three identities together. Okay, we call them Pythagorean identities. So they are the sine square x plus cosine square x equal to what? 1 plus cotangent square x is equal to cosecant square of x. And then 1 plus tangent square x is equal to secant square of x. So generally, any expression involving the trigonometric function can be written in the different forms, okay, in many different forms. So in this case, we may use the identities to simplify the expressions and determine whether two expressions are equivalent. So by equivalent of the two expressions, we mean if we have the expression f1 and f2, they are equivalent if and only if this equation is an identity. So they are equal to each other for all those numbers for which the both sides of this equation are well defined. Now let's look at the page 516 and let's look at the problem 6. It says, write each expression in terms of the sines and or cosines and then simplify. So right now we have the cotangent x over the cosecant x, and we need to rewrite this in terms of the sines and or the cosines. So page 516, problem 6. We have the cotangent x divided by cosecant x. So first, how do we rewrite the cotangent x in terms of the sine and the cosine? Cosine over the sine, right, equal to cotangent. And then how do we rewrite the cosecant in terms of the sine? 1 over the sine, right? Okay. Now we may just simplify this complex fraction. So you multiply both the numerator and denominator by sine x. Okay, and then this guy and this guy cancel, this guy and this guy cancel. And finally, you get cosine x. And in this way, we just simplify this expression involving the trigonometric functions, right? Actually, in this problem, we use identities from the definitions and then the reciprocal identity.